Hello everyone. Yes, we're live. Looks like the other sessions have kicked off, so we might get going here as well because we're running behind time. Today's, before I introduce Jamie, just two things. Remember there's an app. I hope you guys have all got a link to the app. You can log in. If you can ask your questions in the app, then people can sort of crowdsource them up to get the most popular questions. And if you do tweet the hashtag AusCERT2022, you guys probably know that already. So we're behind time, so today's speaker is Jamie Gillespie. Jamie's at APNIC. He's got a fantastic accent, which is from Canada, and he's been around for a long time. He knows a lot about incident response. He's worked all kinds of places, from telcos and Google and AusCERT a long time ago. I think I met you there then. And now he's at APNIC, so please welcome Jamie.
Thanks very much for that. Quite interesting from the previous presentation talking about donating a kidney. I actually donated a kidney last year, so that's a nice little connection. So if you want to talk to me about donating kidneys, I'm happy to do that. Or after this session, I'm not sure if I have to finish a bit early, but if we don't have a lot of time for questions, come see me after the session and at the break times. I'm fairly easy to spot in a crowd, so let's get started. So the presentation today we're looking at is vulnerability reporting on a shoestring budget. So just a bit of background about APNIC to set the tone on why we're running on a shoestring budget. So APNIC is the regional internet registry. We manage IP addresses and allocations for the 56 economies that make up the Asia-Pacific region. We're a not-for-profit organization. We're purposefully open and transparent in everything that we do. We've got approximately 120, getting close to 130 staff now and still hiring. We manage some data centers both in Australia and internationally. We use infrastructure as a service hosting on AWS and Google, multiple SaaS applications and vendors around. But we don't just run typical web applications. We run some of the classic ones that other organizations will, VPNs, SMTP, DNS servers. We also run some of the slightly more unique ones, like purposefully having anonymous FTP open, running Whois servers, and RPKI, and even publicly accessible rsync on purpose. Yes, that is real. And believe it or not, the internet runs on some of this. We do have an IT team internally. Actually, we have two of them, but they work really closely together. We do some internal vulnerability scanning, external penetration tests, you know, the usual thing that you expect an organization to be doing. We also have internal developers that are writing new applications, both for use internally, web apps, as well as C-coded, proper compiled binaries. APNIC has a CSERT team. It was created internally to formalize our incident response procedures and just overall information security work that is going on, everything from security awareness through to preparation for 27001. So early vulnerability reports that we were getting in, we didn't really have a proper security point of contact, at least not one that we were advertising externally. So if there were security researchers that were wanting to report vulnerabilities or security issues to us, they would be reaching out to our privacy ad email address, or sometimes even HR, or just random email addresses that may or may not have existed. Maybe reaching out on Facebook and even LinkedIn contacts trying to contact us. And of course, those are not the best ways. Sometimes they'll get dropped. Sometimes they'll take a while to get routed to us. HR, we tell them to be suspicious of weird emails, so when they get these weird emails, they think that they're scams and may or may not pass them to us. We did get the occasional actual scam message as well, but it's a little bit different in the sense that they don't actually say anything specific. They don't mention us as an organization. They don't mention what website they found a vulnerability in. They don't mention what vulnerability or even the type of vulnerability, and they're asking for money up front. It is a scam. If you take some of the words and do a strict Google search on that, you'll actually find that this is a common copy and paste scam, just trying to get money and probably not even give you any security advice at the end, or something simple like you're missing an SPF DNS record or something like that. So the conception of our VRP program, started off with, well, we should have a security point of contact for security researchers to contact us. And then we'll need to publish that somehow. We'll need to advertise it so people know how to contact us. But if we're advertising a random email address, we would need to set some rules. We want to make sure that people use the email address for the right purposes and they're contacting us in the way that makes sense for both parties. Now this sounds a lot like a bug bounty program when you start adding all of these things together. But we're a not-for-profit organization. We're not huge. We don't have a lot of financial backing for running bug bounty programs like big commercial organizations do. So the question was, could we set this up and run it, and would it essentially be a bug bounty program with the bounties, and would it work? You know, it's basically not a lot of effort to put it up front, and if we get 0 reports, we didn't waste a lot of time on it, so it's not a big deal. But it would be interesting to see what reports people would actually be sending in to us. So this was the start of what we called the Vulnerability Reporting Program. This started about 2 years ago when we were going through the conception of this. At the time, it was about 50-50 whether people were calling their programs VRPs or VDP, or Vulnerability Disclosure Program. Since then, most organizations are leaning towards VDP, but you know, it's an acronym. You can make whatever acronym you want, right? So we went around, we read a lot of other program texts, whether they were bug bounties or vulnerability disclosure programs and reporting program texts, picking the bits and pieces that we really liked from each one and putting together something that made sense for us and learning from hopefully what was other people's mistakes and iterations that they went through. We circulated a draft amongst the IT teams for feedback and improvements. We did our own little, role playing to see how different people would read and interpret it, got that up to speed. We then had used an early template for safe harbor language. This is from a website called disclose.io. They were just starting out with their safe harbor language. It was very American-based with American legal terms and that. But we took that, we passed it by our legal team, got them to Australianize it and make sure that it was something they were comfortable with, what we were saying. And the safe harbor language was starting to get really important. The safe harbor language, if you're not familiar with it, basically says, if you do the right thing and report to us, we won't sue you. And this was because there were many, and still are many instances of security researchers and just random people that find a vulnerability on a website or in a product. They contact the company and they don't have a proper vulnerability program. They reach out and they say, I found a vulnerability, and they get lawyers sent after them. And it's got a huge chilling effect on a lot of security research and vulnerability research that's going on out there. To the point where I'm seeing discussion groups where people are using Tor and Proton Mail email addresses in order to report vulnerabilities and not wanting to take credit because they're afraid of getting sued. Of course, they're mostly American, so, you know, good on them for protecting themselves from legal consequences. But this safe harbor language is getting to be more important in these vulnerability programs. Disclose.io since then has actually come up with a few more regionalized safe harbor languages, and they even have a full vulnerability disclosure program template that you can go in and create your own program with. So some learning for you if you're going through this process more recently now. So the layout of our actual program text, we broke it into a few sections here. We've got background, introduction, what's in and out of scope, report details, and safe harbor. So I'll just go through briefly what they cover. So the background of APNIC, a lot of security researchers don't come and find vulnerabilities because they know who we are. They just see a program or they're scanning across using their tools and they find a vulnerability and then afterwards try and figure out who the company is and who to report it to. So we give them a bit of background and we let them know right up front, hey, we're a not-for-profit organization, here's what we do. We then do the introduction to the VRP, where we actually call it the bug reporting. You know, we value the hard work of security researchers, you know, the usual text that you'd put up front for something. We put the email address that we wanted them to contact to, and that was csert@apnic.net. We did do a little bit of email obfuscation to try and stay off of the spamming mailing lists, and so far it went pretty good. And we also set some expectations for the security researchers. Now, this was an interesting one that we also had to work with internal teams to set expectations. So we made it very, very relaxed. It was basically, we aim to reply within a week, and we aim to close off anything that is higher than an informational vulnerability in 90 days. So that's sort of like the maximum that a vulnerability program would be doing. You don't want to give anything larger than that. And this is important to set the expectations, because if the security researchers are emailing you in and they expect a reply within 2 or 3 days, if they don't get it, they can get frustrated, and they can sometimes go public saying, hey, I reported a vulnerability to this company and they didn't reply and they don't care about security. And we generally don't want that kind of bad PR going across Twitter and everything else. So we set expectations, and we worked internally to keep to them. For the in-scope section, I pushed a little bit on this, and I made it as wide as possible. We literally put in wildcards that basically any domains that we own, we manage, we control, I want to know about everything on these domains. Again, we're not paying out money, so it doesn't really hurt too much, but I wanted to start really wide and get it open as much as possible. Then we listed a few things out of scope. Again, I didn't want to scope things out too quickly because I wanted to be notified about even some of the little stuff that came in, but right up front, we have to make the statement, hey, some of our subdomains may point off to other services, and we use these other services, but we can't authorize you to go and start hacking against Okta, Cloudflare, Zoom, and similar. So we made that right up front. We didn't want any destruction of data, so please try not to do that. Don't try and DOS us. That doesn't really cover anything. Don't social engineer us. We know that social engineering will be successful for a certain percentage of the time, so don't go phishing our staff members, because we want technical vulnerabilities reported in. And please don't show up at our office and throw a brick through the window and say that our windows are not secure, so physical security controls are out as well. For report details, helping people along, there are a lot of brand new security researchers out there. They want to get into bug bounty hunting and things, and they go after these free programs to build up the street cred first. So it's nice to give a little bit of a layout what information we wanted in the reports. And we were pretty successful. I don't think we got many reports that were lacking information that we had to do back and forth getting more details, but just a bit of a list here of what we wanted as a report. And we mentioned on the report details, you know, hey, we are a not-for-profit, we can't pay out major bounties, we really appreciate your assistance. So again, setting the expectation up front, and that reduced a lot of the, oh, hey, can I get some money for this vulnerability type of thing. We put on our safe harbor language. This is a short version, it's about 2 paragraphs long. If you conduct vulnerability research that is in scope as per this program, and you report your findings to us in a timely manner, we will consider this authorized, and we promise not to take legal action against you. Because essentially, if it's not authorized, it could be like a couple different federal crimes that they're committing, both for whatever economy and country that they're coming from, as well as Australian telecommunications laws. So putting that up front, everybody's covered. We also went through, we created a GPG key just in case anybody wanted to encrypt any of the reports being sent in, because it was just going over email. We also created a security.txt file. This, if you haven't seen these before, it's an evolution of the robots.txt, where it's in a well-known directory. Literally, it's a directory called well-known. Where you put your security TXT, and you can see the information there. You can also sign your security TXT file to prove that the GPG or PGP key that you're using is the one relating to it. There is a website that can help you craft these up. They are plain text, so you can do it by hand, but securitytxt.org was a nice little resource to make sure that we were keeping things compliant for anybody that was caring about that. So, looking on the receiving end of the reports that came in. So, our IT teams were receiving reports. We had a ticketing system that we used internally already. So we just created a bit of a queue for that one. We had the email address csert@apnic.net. We were using that for internal purposes. We were subscribing to different vulnerability notifications from different vendors and having that come in. But it was a really great email address, and we wanted to use that one as part of our public program. So we switched things around, used that, and ended up using that for the public side of things. Our IT teams would manage the upgrades of any of the third-party software that we were purchasing and using, you know, your standard WordPress and any of the Apache Nginx, the operating systems themselves, typical things that an IT team would be working on. And then as we were going through and doing some internal tabletops to, you know, practice how things would be working, it was like, oh, hang on, what about these other websites and applications that we're running that are created internally? It's like, oh, that's right, the developers. And we went and talked to the developers, and it was sort of like, hey, we weren't forgetting about you. We're running this program. Honest, we weren't forgetting about you. And that started leading to a whole separate discussion, because initially it was the IT teams and upgrading software that, you know, had patches available for. So at this point it was like, oh, hey, we're going to be doing this thing where we ask people to hack our systems, and we're going to be getting vulnerability reports, and some of them are going to be about your software. So it had some interesting discussions. It had a little bit of back and forth, as you can imagine, but we basically worked with them to inject into their development cycle, into their release cycle as well. So from here, we were looking at confirming vulnerabilities to make sure that when we send them something, we need them to reply quickly to confirm whether it is a vulnerability or not, to work on fixing the vulnerability in the time frames that we're trying to advertise here, to go through testing procedures and work with us on testing so that we can make sure that the fix actually closed the vulnerability properly, completely. And then their release cycles for pushing into production to make sure that they can get pushed maybe a little bit quicker or on a slightly reduced schedule for what they may have normally been doing. So it was a really good experience to work with the development team and really get some security processes working with them. So we had a bit of a premature birth for our vulnerability reporting program. Just 5 days before we were going to be publishing the website with the program and everybody, and everything, someone actually sent us a vulnerability report. I think I'd put the security.txt file up, so they actually had found the security.txt, found a vulnerability, and sent us an email report before the program actually went live. So it was quite interesting. It was an actual vulnerability, not just a bit of a low-level thing. So cross-site scripting in a display name field. So it was a reflected cross-site script. Oh, no, sorry, this one was stored cross-site scripting. So it was a real vulnerability. Gave us a good way of testing our procedures, testing how everything was running, because we didn't want to get flooded. You know, the fear was, what if we get 10 reports right away and we have trouble managing them with the other work that the IT teams are doing, with the other work that the developers are doing. So it was a good testing for that. It also led us to add a thank you section, sort of like a Hall of Fame section, onto our VRP website page, and giving thanks to them. So thanks to Denny, who is our early bird security researcher reporting in. So when we wanted the program to actually go live, we finally published the web page that had all of the program text that I detailed before. Then about 5 days later, we then put up a blog post. Now the blog post was on our own blog, and this was pretty much the extent of advertising of the program. Again, we wanted to start slow. We weren't sure if it was going to get a lot of attention or not, so we went for a very calm and quiet way of advertising that the program was running. So the number of vulnerability reports, here you can see as month by month, it did start off nice and slow. It was great. One report a month. It helped us, slowly go through, get people involved, do deeper dives into the program and the reports, how we were doing replies, and everything went really, really well. And then it picked up. So you can see here, it's spiking up to about 13 reports in 1 month, and that was quite a lot. And this was with no additional advertising of the program. We didn't go out on any of the other websites. We didn't announce it anywhere else. There's a bit of suspicion that it might have been one of the hacker pen testing boot camps actually picked up and saw a new program, so they advertised it to their local group of the new people that were going through their pen test boot camp program. There's also some, quiet assumptions that could be made. A lot of these reports were coming from slightly more northern hemisphere. That's around the time of Christmas time and then summertime, which may be school breaks as well. So, a bit of assumptions, but a lot of the people reporting, we didn't get a lot of details from them. So, it is what it is from there. We did have some quiet times, went back to 1 report a month, and then it went back up again. So, this worked out really well. When you look at this as the orange line as the cumulative number, just over a year, just under a year and a half, we ended up with 81 unique reported vulnerabilities that came through, which was absolutely amazing. So let's break these down and see what were these 81 reports. So we had 16 that were information disclosure, low-level information disclosure, maybe exposing version numbers or exposing some log files that didn't have anything that was sensitive in them, but things that, shouldn't have been disclosed in the first place. We had 10 reports that were for reflected cross-site scripting, so that's where it's not stored in the database, it's simply just brought in by the URL and then displayed back in the web page. 5 reports of denial of service, they were technically denial of service. They didn't DOS our systems, but they basically went in and said, hey, you don't have rate limiting on this. It could lead to a DOS attack. It's like, cool, thank you for not actually executing a DOS on us. 5 reports of stored cross-site scripting, so we're getting a little bit higher priorities here, and 4 clickjacking attacks. We actually ended up with 3 priority 1. So priority 1's the highest priority for this system. We ended up with 3 P1 events. These were SQL injection and sensitive information disclosure. So you can see the nice little graph there, as you'd expect. The lower level stuff has the most number of vulnerabilities. So one of those P1 vulnerabilities actually turned into an incident. So this was something that we weren't really preparing for. We didn't have a standard operating procedure or a playbook for this, so we basically quickly converted it to our incident response plan. This one ended up where the sensitive information was actually a Google Cloud bucket, sort of like an S3 bucket, that was not properly secured. And that in itself wasn't a problem because it shouldn't have had sensitive data in it. But that then was combined with an accidental backup copy of a database that did have some sensitive data in it. So those 2 things combined turned this vulnerability into an incident. We went through, managed it internally, did our communications with affected parties, and then as the responsible organizational thing to do, we then made a public announcement about what was happening and what went through. So it was picked up by a couple media outlets because we went public, so of course they can make it public. But yeah, it was an interesting one. Luckily, it didn't have any large or lasting damage, but it did require us to go through, review all the sensitive information that was there. Luckily, it didn't quite make it to notifiable data breach. It wasn't information that would have caused significant damage to the affected parties, so yay on that part of it. But it was an interesting case. And again, this was one of those cases where, hey, this really bad thing happened, but isn't this a great success story for the vulnerability reporting program? Because this was a random security researcher who reported it into us, and was not asking for a bounty. We didn't have to pay them anything out, and our systems are more secure because of it. So really awesome results. It was one of those great things. It's like, if we don't get reports, that's okay. If we do get lots of reports, well, that's a success measure as well. So it's almost a win-win. This is a nice breakdown of all of the different classes of vulnerabilities that came through. The red highlighted ones in the bottom of the middle there, the sensitive information in SQL, those ones are the P1s. The orange ones on the left and right-hand side, the DOS, stored cross-site scripting, and host header poisoning, those were P2 incidents, so still quite high priority incidents for us to manage and close them off. The host header poisoning was quite an interesting one. Took a lot of work for them to go through and actually would have been almost an authentication bypass. So really amazing to get that found and get that closed off. I don't think there's anything else too interesting in here. You know, you can see the one of each on the right-hand side. Some of those are very lower priority things that weren't really too serious, but you know, we closed them off because we can and we should. So who was reporting the vulnerabilities to us? So we had 45 security researchers that sent in one single report each. We had 9 researchers that sent in 2 reports each, 3 that sent in 3. One researcher sent in 4 reports, and another researcher sent in 5 reports, which was really awesome from them. Most of the multiple reports came in on the same day, so they were doing a lot of work in a short period of time as opposed to a long-running engagement with us. Half of them were for the same service, so the security researchers were poking around on one system in a lot of different ways, and the other half were across different services. So they were looking for the same class of vulnerability across different services in our network. So quite a mixture of ways that security researchers are approaching a program like this. We also received 33 duplicate reports. So the reports that were shown here were unique and verified. So anything that is spam was excluded, and the duplicates are excluded from these numbers and graphs that were shown before. Most of these duplicate reports were within the first 4 months of the program while things ramped up very quickly. So people were finding the same sorts of things at around the same time. So we closed them off, merged it back in with the main one, and didn't have to give credit. It's credit only for the first person who reports in. So some of the lessons that we learned from this program, so VRPs, VDPs, and whatever you want to call them, are useful to complement your existing security controls, tools, and practices that you may have. Having that extra set of eyes, or 80 extra sets of eyes across your systems helps you find the things that you might have sort of had a blind spot on or didn't have the tools and technology to go deep into some of your systems where some of these vulnerabilities are going to be. Especially if you're writing some of the code yourself, you can't just look up version numbers for tools that are publicly written and exposed. Good communication with internal stakeholders is really important. This is when you're creating the program, when you're launching the program, and while the program has been running. So the before, really important to find the developers, find everybody who's going to be affected once the program is running. While it's running, people want to know what's going on, and keeping that communication open both ways. Because it's not just good enough for you to tell an internal team about a vulnerability, you need to get information back so you can then communicate with the external reporter and let them know. Again, trying to stop them from having a bad experience and ending up on Twitter saying, APNIC security sucks. And after launch, one thing that has worked out really well is we've embedded even more security engagement with our developers. So we now have a fortnightly all developers meeting where they discuss, technical controls, looking at architecture, but we've got a standing security item where we go over any of the vulnerabilities that have been reported in the past 2 weeks, and we look at the root causes for them. So we're not after a blame game for individual vulnerabilities, but hey, we got 3 vulnerabilities that all relate to input validation and not sanitizing input. So, raising that, doing a little short point-in-time education to the developers so that hopefully new issues don't get introduced further down the track. Having standard operating procedures and response templates makes things really easy for the people that need to be handling them, and make sure that you have a consistent response. There's nothing worse than having different IT on-call engineers having to write the same type of information, but using their own language. Maybe using it maybe a little bit incorrectly, English being a second language for some of them, and then also the end of the reporter who's receiving this reply may be misreading it, misunderstanding it. There could be some language issues as well. So having standardized templates, copy and paste makes it easier, makes for clear communication and clear expectations. Bounties aren't required to launch a VRP. 81 reports in just under a year and a half is an amazing result. I'm sure there's other numbers that haven't been published that may be better, but I think it's been an excellent result from here with 0 bounties being paid out. And management reporting gets harder the more security vulnerability reports that you get in and the more detail that they want. We did the standard thing. We started off with a spreadsheet, and it very quickly got a little bit out of hand. So it turned into a large spreadsheet. Some of the management team were asking for time frames from a certain point in time to another point in time across all the vulnerabilities, but we weren't tracking those. We were only tracking initial report and closure, not the times in the middle. So we had to expand the spreadsheet. It made it a little more difficult to deal with. So what's happened since then? Around the 1-year mark of operations, we started comparing different commercial organizations that do VDP programs. They come in, they handle the triage and deduplication and initial communication. We selected HackerOne from that program. It was really close, but they all do roughly the same sort of thing. So we've gone with HackerOne. HackerOne now receives the reports, do the initial communication, do the triaging, make sure that deduplication happens and that it's legitimate for our systems. And then we only get the report after it's all being cleaned up. And it's basically, here it is in a nice, easy to digest format. Our IT teams then only have to route that report to the correct internal team and then pass it back and forth. So a lot less work for our internal teams to manage from. HackerOne also does some advertising, so we've actually gone a little bit more public with the program from there. We've updated our VRP webpage. We've removed the email address as the primary way. We're putting in the HackerOne form so that we get formatted, structured information rather than just free-form email coming in. We've expanded the out-of-scope list. There's a few things that people routinely kept coming at to us and saying, oh my God, you have FTP open to the world. It's like, yeah, it's all good. It's expected. The ones that were a little bit more interested in it said, oh my God, not only do you have FTP, but you have all of these security certificates. And it's like, yeah, those are the public keys. Those have to be exposed. And the revocation certificates, those have to be exposed as well. So it's all good. Thank you for noticing, though. Rate limiting issues that didn't deal with authentication, yeah, you're going to be able to DDoS anything on the internet. So if it's not DDoSing our authentication, don't worry about it. Similarly, cookies. Yeah, cookies need to be secured. But in reality, if the cookie is just relating to just tracking, it doesn't give any special access. So if the cookies aren't relating to authentication, yeah, we don't want to hear about it. Some of the third-party cookies don't come as HTTP only or secure. But again, there's no privileged access relating to them. And of course, the Hall of Fame, the thank you list has grown a lot, and overall, APNIC is more secure of it. So it's been a really successful program for us. And it's been great to be able to show this to all of you in case that you're thinking the same things and wondering if a program can be run without bounties, what the success can be, and what types of vulnerabilities might be found and reported. So with that, that's the end.
Yeah, thank Jamie very much. Sorry, guys, we're trying to catch up a bit of time. Jamie's around, and of course, he's everywhere on the internet. Have you got your contact details slide there, Jamie? Might be...
I don't know if I had it. I'm easy to find.
Yeah.
Jamie at apnic.net. So.
What a handsome man. Here's a present for you, mate. Yeah.
Thank you very much for
Cheers.
that.
Thanks, Jamie, again. And the next talk up is going to be Kyle. If Kyle wants to come up from Octopus Deploy.